Hi, welcome to P2P Drive. My name is Johnny Arena. We are part of the Knights Foundation School of Computing and Information Sciences. With me, I have George, Gerardo, Martin, Dominic, and Sean. Our instructor for this semester was Dr. Masood Sajjadi, and we will be presenting our project idea for this semester. So we were sent to solve the problem of file storage. It began as a file storage system, but we quickly transitioned to a file sharing system using peer-to-peer technology. We looked at the opposing ideas, such as Google Drive, OneDrive, and other technologies, and we realized that they have security. One of their biggest flaws is that there is still security flaws, and that they're still centralized at the end of the day. So what we designed was a decentralized file sharing system for peer-to-peer communication with an encrypted level of security to provide authenticity for its users. Um,
All right, so what is IPFS? IPFS is a decentralized system for accessing files, websites, data, and applications. It does this by finding data related to its content as opposed to its location. So where normally a URL would be used to look up information by its location, content identifiers known as CIDs are used to point to that information in IPFS. An example of a CID is a long string of letters and numbers like the one we have listed below. Next slide.
So, how does IPFS receive and return files? Basically, a file gets split into a Merkle DAG representation of said file. A Merkle DAG is just a data structure which splits itself into distinct nodes. Each node is then given a CID, which is a hash of the content of the node. Each one of these small nodes is then sent to a distinct peer into the IPFS network. Each peer will hold its own part of the file. The IPFS then later stores which peer has which part of the file in a distributed hash table. This table is then later used whenever we need to retrieve the content. On the chart below, you can see the way the hashes work. The hash that you get from uploading the file is a top hash, and you can derive all the hashes of the other blocks from the top hash, allowing you to then later retrieve all the files from the different peers very quickly.
So these are the front-end dependencies that we used for this project. So React.js, of course, is a JavaScript library. We tested our API using Postman, and user icons was a React library that we used for creating the images for the About page.
We also used hero icons, which is a royalty-free icons to, you can add flair to your entries on the site. Bootstrap, which is basically an open source CSS framework, and we have used Headless UI, which is a library of unstyled, fully accessible UI components.
and then we have Tailwind CSS, which is a open source CSS styling framework with Prefixer, which also helps with the Tailwind CSS styling. And then for file retrieval and file fetching, post and hooks, we used Axios as our main source.
What's going on, guys? My name's Dominic. I worked on the back end as a Capstone 1. These are the frameworks or the dependencies and libraries which we used on the back end. We put Golang here. This was extremely helpful. This is a IDE made in specific for Golang. Very helpful. Fiber, we had used this as opposed to Gin. This is a very fast, very efficient HTTP protocol. So we decided to implement that. Swagger, this is essentially how we have our API documentation. It's all done using Swagger UI. And we also used MongoDB for our database. It's a relational database. We have user and user files, 2 different collections, and MD5 as well, which is something that works very well with Mongo in terms of encryption for user security.
So as you can see in our presentation, we have the results of what we've come up with this semester. Um, the the top right is the about us page. Our top left is our documentation is using Swagger UI. It's an API implemented in the background and in the backend that does most of our documentation for us, and we can customize it afterwards. Then we also have on the bottom left an example of our register page. This register page communicates with the API to send data to the API, and then the API sends the data towards the database and retrieves a status depending on whether the account already exists or whether it's been stored. And then on the bottom right is our dashboard. This dashboard is the home main page. After you log in, you are given a token, and then once you're given a token, you're authorized to access this page. Without it, you cannot. And this is where you would handle and see all the files that are in your node, and you would be able to upload files and download files using the buttons or the search bar if you have the hash itself. So for this year, we made this project from the ground up. There was a lack of documentation, and we pretty much designed everything, most of it ourselves, using, of course, the documentation from IPFS and whatever available resources there were. But for the future, these are things that we were not able to get to. For the future, I would recommend adding a settings feature for user customization, something where you can personalize how the files are displayed, or how the account or how the user sees the page. Another thing that we would like to add, we should think it should be added for the next semester or for the next group, is a status method. So this status method would return a detailed list of connections with other nodes. And it would show the address, it would show the ping, and a lot more information that would be very helpful for the user. Um, Another thing that we would like to implement in the back, especially, um, is the acceptance of folders and directories. So for right now, our program only works with files. We have a good range of file types that is accepted, and we would have loved to see zip files and folders and other types of directories implemented, but unfortunately we couldn't get to that. And then we the next thing that we would have really liked to hit was the encryption. Our encryption, we had to result to MD5 because it was more compatible with Mongo. But MD5, it is depreciated, and even though it does work with Mongo at the current moment, it's not very efficient, and it could be. We believe it could be. We could use something a lot better, such as AES, which would benefit us a lot more for this project. I just want to give everybody thanks for viewing our presentation, and we are out. This has been P2P. Hope you guys have a great one.